to the textbook that we're trying to review, and it is Modern Computer Vision with PyTorch. I highly recommend the textbook. So let's look at comparing AI and traditional machine learning. Now, by AI, in this case, they're actually talking about deep learning. So I guess that should be corrected because traditional machine learning and deep learning is under AI. So it should be comparing deep learning and traditional machine learning. Anyway, so in traditional machine learning approach, the algorithms that you have in this approach, like random forest, random tree, support vector machine, SGD boost, and multilayer perceptron, you must have heard of all of that. So those are the algorithms that are in these categories. So in these settings, first, before you can apply those algorithms, logistic regression and all those, first, an expert, somebody who knows the domain of the problem, needs to first of all identify the features that needs to be extracted from images. Now we're talking about computer vision. For instance, the person needs to identify, oh, for you to be able to identify a human being, you must have like two hands, two legs, and two eyes, a nose, a mouth. Those are features. Oh, for you to be able to identify a dog, you must have a tail, you must have four legs. So those are features. So first, an expert needs to do that. So when they extract those features, then you now pass it to an algorithm that can learn those features to tell whether the image is of a dog or not. So the diagram here shows that. So first, the expert needs to sit down. So this process is what the deep neural network took away. This is what we refer to as feature engineering. It's very laborious, it's very time consuming. Sometimes it's not even feasible if the expert is not available. Then it takes a lot of time. So this is where you have bulk of the work, and it's not scalable. As you have new data point or novel point, the expert has to come back again and start redesigning the features. So you do the manual extraction and engineering, then the output gives the features, then you can now feed it to with a shallow structure, which we refer to as shallow learning. So this is an example that I explained. You want to recognize a dog, so the expert needs to give us what makes a dog and all of that. So that's there now. But in the case of neural network, that has been taken away. So it combines the feature extraction and then use those features for the whatever we want to do, whether it's classification with little manual feature engineering. The only downside of the neural network is that it requires lot and lot of data set, label data set. You need to be able to label the data set and say, oh, this is a dog, this is a cat, this is an elephant. So that's the downside of that. It requires a considerable amount of data set. So on the high level, this is what you have for the neural network. You get an input, then you just have a gigantic black box that does the end-to-end selection and gives us what we need. So thank you very much, and next time we'll learn about how the various components of the neural network. See you in the next one.